Hi everyone, Ms. Caulfield here. In this video, we are going to be taking a look at separation techniques, in particular filtration, evaporation, chromatography, and distillation. So the first separation technique that we're going to take a look at is called filtration. We use filtration when we're trying to separate larger solid particles from liquid particles. So we're going to be using this when we have a liquid and a solid mixed together in a heterogeneous mixture. The way filtration works is you take the mixture of the solid and liquid and you pour it over top of a filter paper. So this is going to be important. That filter paper has small holes on it, also called pores, and the liquid particles are small enough that they will be able to pass through the pores, but the solid particles are too big, so they will be trapped on the filter paper. The liquid that goes through the filter paper gets collected at the bottom and is known as a filtrate, which is going to be just the liquid component of that mixture. A good example of filtration is making coffee. When you make coffee, the coffee grounds get trapped by the filter paper while the water is going to pass through the filter paper. The next separation technique that we're going to be taking a look at is this concept of evaporation. So evaporation is also going to be used to separate liquids and solids, but the solids in this situation are going to be smaller and completely dissolved solid particles that we're trying to separate away from our liquid particles. So because these particles are so much smaller, if we were to use a piece of filter paper to try and separate them, the solid particles would actually be able to pass through the filter paper with the liquid particles. So we have to come up with another alternative for how to separate these two things, and that is why we use the process of evaporation. When we're using the process of evaporation, you're going to be applying a heat source to the mixture, and that heat source is going to cause the liquid particles to boil and transition into a gas. When they transition into a gas, they're going to go ahead and just join the atmosphere, and what will be left in the evaporating dish or the evaporating basin is going to be just the solid particles. Next up, we have chromatography. So chromatography is used when we're trying to separate substances based on their weight. Lighter particles are going to be carried further along the chromatography paper than heavier particles. Chromatography paper, which is pictured up here in this top image, is super absorbent. So when we put water on it, the water is going to move along the chromatography paper by itself. Chromatography is a separation technique often used for separating pigments. In the first image on the top there, we're looking at the separation of pigments of color within black ink pens. Chromatography is often used in crime scene testing, paternity testing, and was even used to help and identify the soldier who was buried at the tomb of the unknown soldier. Because DNA is going to be carried along the chromatography paper the same way that pigments will be, so it's easy for scientists to try and identify the DNA between different people or different substances. The last separation technique that we're going to take a look at in this video is distillation. Distillation is when we're trying to separate one liquid from another liquid, and we're able to do this through distillation because the two different liquids are going to have different boiling points. This part is very important for the process of distillation because when we have two liquids mixed together, which we see in this flask here on the left-hand side of the apparatus, we're going to heat that mixture of two liquids so that one of the liquids is going to boil faster than the other. When it boils, it's going to go ahead and transition into a gas, and it will move up into the top of this flask. If you notice, the top of the flask has a stopper, so the gas has nowhere to go. Since there is the stopper, the gas actually is going to get funneled down through this cooling tube where it will condense back into a liquid. it will continue to travel through the cooling tube and eventually drip into the receiving flask at the other end of the distillation apparatus. So this is how we're able to isolate or separate two liquids that were originally mixed together.